Thank you for having me here. Yeah, I feel like a singer now, so excuse me about the difference in voice signal. So thank you, Simon, for a great presentation, and I will continue on with this building information modeling and add another perspective. This time on smart facade. This is my specialization. This is what I teach at University of Southern Denmark, and also part of my experience at Politecnico di Milano. So first of all, why smart facade? So is it only a fancy word, or there is something meaningful behind it? So far we can identify that construction sector is actually the most worth sector in the world, and the business is estimated at $1 trillion worldwide. So it has a big potential, and despite that, building industry is the only industry that hasn't any production increase in decades, and actually it's falling, and that's really sad, having in mind all this potential. So one of the aspects that can bring this potential further is building information modeling, and this is the so-called framework and the foundation that we can all build upon and learn from each other, and build this collective learning experience through the software and services like Marius and his team provide. So I'll present you today the story about the facade and the smart facades. As we all know that building consumes around 40% of the energy worldwide, and the facades account for somewhere between 40 and 60 of that cost, depending on the complexity of the facade. And also, we all spend approximately 90% of our time inside. Obviously, this study was done probably in Nordic countries, so I guess here the percentage is much lower. But anyway, it's very important to know and to understand how we can build smarter facades, not only for the building purposes and for performance of the buildings, but actually for the occupants and for humans. And there is a whole new revival of the human-centric approach, and you can call it even Renaissance in that sense, that we are now focusing more and more on humans inside the building and their well-being, productivity, happiness, experience, etc. So what I want to point out is that we so far had the physical world, and the most valuable assets in this physical world were, for example, oil. But nowadays, this shifts completely to the virtual world. So now our most valuable resource is not physical, it's virtual, and it basically doesn't have any limitation in that sense. So it's not exhaustive, it can only grow, and the growth is not linear, it's actually exponential. So my background in facade experience, in facade design and engineering, is actually on the worldwide projects while I was working for Vittorio Grassi Architecto in Milan, and also being part of environmental design team within Hen Architects in Berlin. So I won't go into detail about this project, just to mention that there were many projects that I've been part of, and these projects actually are scattered all around the world. So I learned a lot about the context, about different aspects that drives the facade design and engineering, and different requirements. So ranging from, for example, Italy to Yakutsk, officially one of the coldest places on Earth. So like you can see, the facade design is completely different from what I presented here, that is south of Italy stadium. So we have different loads from the climate, but not only climate. There is a lot of aspects coming from cultural, political, corporate, just name it. So you have to be able to understand the context and to work to fulfill the goals, not only of clients, but since we design buildings, we design not only for clients, but for the whole community and for people live in these cities and that use this space that every day pass through the city and look in these buildings. So the value of the building is far more than the only value of the property or the client value. So how do we design? In a sense that we keep track on all these values and ensure that at the end of the process we deliver these values. And this process is quite scattered, and it's usually it has a lot of flows, and you cannot secure the value until the end of design because of many issues that can appear along the way. So the only thing that we can do is to bring this process to the digital world, and through the help of building information modeling and particularly geometrical aspects of it, because we don't want to refer building information modeling only as a geometry tool. Actually, information is far more than geometry, and this is the foundation that we and my profession actually want to build upon. So we want to extend this work from the physical to the virtual, and these concentric cycles shows actually the complexity and the increase of complexity as we rise from 2D to the computational design. And it turns out that the only the central core that is computational, or call it beam design, is able to track, and that is the central point that actually integrate and connect all these values and the aspects in the design chain. So how we start from the inputs and how we deliver outputs, there are a lot of possible paths and many degrees of freedom that we can choose, and with this degree of ability to make something wrong. And if you're just starting analyzing some of the aspects like performance, there are many performance that you can optimize, and usually the process is that you optimize one by one, and at the end you have a whole picture, but you haven't done multiple optimization, or this optimization is actually quite computationally expensive, and it lasts long, and on top of it we have many other parameters. So imagine the complexity of work and someone telling you that he has optimized design. So that's virtually not true, at least not in this phase of design. Maybe in the following decades we'll be able to track all these aspects and to know more about the context that we designed and actual design solution that we are proposing, and to make better clues on these solutions, because we know all the design landscape. Because essentially without designing a landscape, we don't actually know if we improved or if there is any area of improvement. So in that sense, virtualization would help, and this kind of structuring of performances and aspects would be able to actually improve a lot the design process, and it can be compatible with the new coming technologies and big data and artificial intelligence. So as long as we can build rule set on design and build better design workflows and also performance workflows, we'll be able to deliver better outputs. And this is one of the approaches that I cannot play it. Yeah, okay, just keep it. So I wanted to show you a video where you actually can upload your design in a building massing, and it can extract automatically information out of it and propose structural solutions. So within a matter of seconds, it can deliver you optimized solution to a certain degree. Of course, it's flexible, so you can change it, but it saves a lot of time. And I hope this kind of approach will extend to other performances like optical, thermal, just name it. And at the end, it will be all integrated. And why this is important? bring it to the virtual world, because we can store all this data. And what I learned in the practice is that every office is actually working on simulation, on design that is stored just locally, and we cannot extract, even with our own firm, we cannot extract this info and use it for the next project, maybe to some extent, but this potential is much, much higher. And if we have this collective learning and collective upload and connection through the digital services like online, we can extend it, and we can make the better systems. So this is just the mapping of the whole innovation value chain in a facade. So whenever we want to propose some new facade system, we need to go through all of these steps, and going through all of these steps takes really a lot of time, and it's really expensive because you need to do several testing along the way, and you never know about the outcome, because something you imagine probably can have different performance, and then you need to optimize, going back and forth, etc. So I will present you one of the facade design systems that I designed during my PhD, and that takes into account not only design, but not only engineering aspects of facade, but try to integrate it. And this is the aspects in education and in our research at University of Southern Denmark that we are promoting. So we are not just architects, facade designer, or facade engineers. We are actually integrators, and we make better looking but better performing skins. So this was the original idea, to design a facade system that has integrated photovoltaics. So basically it can generate energy, but it can also work as a daylight redirection system and optimize daylighting level indoors and improve the comfort, but also provide this kind of fluid aesthetic to the building skin, because current building skins are usually flat, and they do not use all the optical potential of the facade like glass definitely has. So I proposed a system that is flexible enough to provide degrees of freedom for performance simulations to determine the actual module within that system that will be placed to a certain location on the building skin. So in that terms, design is not static. It's flexible, and it can adapt to the climate loads. So based on the simulation, the population of the facade modules can change, and it can determine the local climatic loads on the building skin. And of course, everything is done parametrically, so in computational way to track the performances of the geometry, and also to use it for optimization. And this is four modules system presenting one of the frames that can be used. This is a cable net, and this is how it can look like. So it has different rotation, and there are different modules, but actually the integrity of design is kept the same. It has certain flexibility, and this flexibility is actually what matters in facade design, because we are facing dynamic loads from the environment and from sun, and it is important to understand all these requirements and provide right comfort for the building occupants at each point in time. So it is a very challenging task. And these are just some of the performances that were considered. So everything from views, energy generation, energy redirection, light behavior through the facade skins. And this is one of the infographic that I provided for this system, explaining the difference between vertically oriented photovoltaics. So this presents actually the energy production on different orientations, so on west, east, or different cardinal directions. So obviously this one was done for Milan, so it has a greater energy production on the south facade. But this is what happens when we just rotate it for the 50 degrees. We gain at least 40% in the energy, and we improve also the daylighting indoors. And this is just one of the aspects that we can consider this kind of approach. The other aspects might be reflected to the holistic picture of the building design and designing for energy efficiency, because what we consider usually as architect is a construction cost. So it's basically investment costs, and a lot less architects actually design for the total costs, including the operation. So what happens is that you actually have the low investment cost, but this cost grows much more than the cost that would be calculated if you invested a bit more and then have lower running costs. So there is an optimal curve, and currently this curve falls within nearly zero energy buildings, but this do not consider any kind of photovoltaics integration. So when we have photovoltaics, we can extend it further to the left on the plus energy buildings, and you can see that the cost is actually going in reverse, meaning that we can earn from the building, and that puts completely another perspective on the building design, because in this case, facade becomes a business case. Basically, it's not only about static building system; it's about potential over the lifetime of the project.